Hi, and welcome to this video. In this video, we're going to be discussing when a graph is decreasing, increasing, concave up, or concave down, and how you can figure it out. First, let's define the terms. If in a graph like this, as you can see, the slope is negative, which means that it is decreasing. So decreasing is when the slope is negative. Increasing is when the slope is positive. And concave up and concave down is actually pretty interesting. So in something like this, this has both concave up and concave down. But that might be a little interesting. What do I mean by concave up and concave down? Well, concave up is when the slope is increasing. And concave down is when it's decreasing. So what do I mean by this? Because we already have that, right? Negative, positive. Well, there's a difference. For example, let's, in concave up, it can be a negative slope, but the slope has to be increasing. Or it can legitimately be positive and increase like that. Concave down is just the reverse. It can be positive, it can start with 4, but as long as it's decreasing, it's concave down. So right over here, we have concave up, and right here, we have concave down. But how do we figure out from a function where it's increasing, where it's decreasing, where it's concave up, and where it's concave down? Well, let's look at some important details here. Everything is related to the slope. Here, slope negative. Here, slope is positive. Here, it's whether the slope is decreasing or increasing. So all of these are dependent on the slope. And what's another word for slope? You guessed it, the derivative. Let's see, we have this function f of x, and we want to see when it's increasing, when it's decreasing, when it's concave up, and when it's concave down. Well, in order to see whether it's decreasing or increasing, that's just dependent on whether the slope is negative or positive. So we can find the derivative and just see whether it's negative or positive. So the derivative, just use power rule, 3x squared plus 2x plus 1. And now we can see whether or not it's increasing or decreasing by first setting this equal to 0. And once you set this equal to 0, actually just to make the numbers a little bit nicer, I'm going to make this negative right here. Not there. Right here. And that'll just make it a little bit nicer. We can do a little factoring. You can see here that this will get us 2x. So this is equal to 3x minus 1 times x plus 1 is equal to 0. So we find that x is equal to 1/3 and x is equal to negative 1. Now I'm just going to draw a little number line. I'm going to put these 2 points on it. So these points are where f prime of x is 0. And that means in these intervals, it needs to be either positive or negative because these two are the only points where it's 0. And also, if you were had a different function, you'd also might want to check whether f of x is undefined. But in polynomials, it is always defined. So we don't have to check that. So what we can just do is that we can plug it in. So first, we plug in -2. This is going to be going to be 12. This one's going to be -4, -1. This is positive, which means that this point in the graph is increasing. Here, just put in value, I'm going to do f prime of 0. As you can see, I'm just trying to put the easy numbers. That just results in -1, less than 0, decreasing. And then here, f prime of 1, they're all going to be positive, except for this one, but that's cancelled. So this is going to be greater than 0, increasing. So this is how to determine whether a graph is increasing or decreasing. But what if we want to find out whether it's concave up or concave down? Well, remember that it's determined by whether or not the slope itself is increasing or decreasing, not the fact of whether it's positive or negative. So technically, you're trying to find the change in slope, which is just the derivative of the derivative. So we're going to find the second derivative. So let's take the derivative again. That's going to be 6x plus 2 is equal to 0. This one's really straightforward. X is equal to -1/2. No, sorry, -1/3. So I'm going to again draw a number line, put -1/3, and this time we only have two ranges to check. This range right over here, and this range right over here. So this first range, I'm just going to do f double prime of, let's say, -1. This is going to be -6 plus 2. This is going to be less than 0. So here it's going to be concave down. And then here, we're going to get f double prime of, let's say, 0. This is going to be positive. So this is concave up. So I hope this video was helpful and taught you how you can use the derivative and the second derivative in order to find whether the graph is decreasing, increasing, concave up, or concave down. See you in the next video.